Okay, continuing with our right triangle trig, the next thing we're going to get into is this whole idea of solving a right triangle. So this means that you'll be given one side and one angle, and then you'll have to find the other sides and the other angle. Now, finding the other angle is simple because it's just a matter of realizing that the two acute angles have to add up to 90 degrees. So if one is 75, I guess we'll label this triangle. Oop. We'll label this triangle A, B, C. Generally, the right angle is going to be called C because the hypotenuse is usually side C, which is opposite angle C. So if we know angle B is 75 degrees, then we know that angle A is 90 minus 75, which is just 15 degrees. So that's the easy part. Now, finding the missing sides, right? So this is B, this is A, and this is C. So when we're trying to find, let's say, side A, for example, right, using the given information was the 75 degrees and side B, which is opposite that. So we got to think about what we're looking for and what we have. So we have an angle, we have the side that's opposite that angle, and we want to find the side that's adjacent that angle. So we're dealing with opposite and adjacent. So since we're dealing with opposite and adjacent, we're going to use the tangent ratio, right? Because tangent was the opposite over the adjacent. So what we're going to write is we know the tangent of 75 degrees, right? Because now we know what the angle is. It's not tangent of theta, it's tangent of 75 degrees, and it's going to be equal to the opposite, which is 100, over the adjacent, which is A. So how can we solve this? We can basically think of this as cross multiplying, right? So we have A times the tangent of 75 equals 100. So we have A times the tangent of 75 degrees equals 100. And then we isolate the A just by dividing by the tangent of 75 degrees. So there's our exact solution, right? Our exact solution is that A is 100 divided by the tangent of 75. Now we're probably going to want to round this to, a tenth of a foot or something like that, or a hundredth, but we'll put this in the calculator now. And you just got to be careful when you're working with the calculator that you're in the correct mode. In this case, we're dealing with degrees, so I want to make sure when I go to mode, I'm in degree mode, which I'm not. So I'll change this to degree mode. And now I'll go back home and I'll do 100 divided by the tangent of 75. And that's going to give me 26.8, let's say. So A is going to be 26.8 feet. So that's our side A, right? So we knew angle A was 15 degrees, side A is 26.8 feet, and now we're going to want the hypotenuse, which is C. So now when we're doing the hypotenuse, again, using our given information, we have the angle, we have the opposite, and now we want the hypotenuse. So which of the trig ratios involved opposite and hypotenuse? Opposite, hypotenuse. That's the O part. So it's sine of 75 is opposite of a hypotenuse. So we're going to set up a similar equation to what we did before, but now it's going to be the sine of 75 degrees is the opposite, which is 100, over the hypotenuse, which we're trying to find, which is C. And we're going to solve this the same exact way we solved the other one. So cross multiply, so it's C times sine of 75 degrees is 100. And then we're going to divide by the sine of 75 degrees. So here we have 100 divided by the sine of 75. So there's our C. It's 100 divided by the sine of 75. But again, I'm going to put this in the calculator. and that's going to give me 103.5. So C is 103.5 feet. So now we found the other two sides, we found the other angle, so now we're done. Right, so angle A was 15 degrees, side A was 26.8 feet, and side C, the hypotenuse, was 103.5 feet. So the other thing that you probably recall from trig in the past was this whole idea of the special triangles, right? You had this 45, 45, 90 triangle, and then you had this 30, 60, 90 triangle. So the 45, 45 right triangle was called an isosceles right triangle, right? Because it had two equal sides. So if we say the length of a leg is 1, both those legs have a length of 1, then the hypotenuse was the square root of 2. So now that you know that that's the setup for that triangle, right? Each leg is 1 and the hypotenuse is the square root of 2. You know what all the trig ratios of 45 are, right? So it's the sine of 45 is opposite of hypotenuse, so it's 1 over the square root of 2. The cosine of 45 degrees is the same. It's 1 over the square root of 2. The tangent of 45 degrees is opposite over adjacent, but they're both 1. So it's 1 over 1, which is just 1. And then the other three are the reciprocals, right? So the cosecant of 45 is radical 2 over 1, which is just radical 2. The secant of 45 is the same. It's radical 2 over 1, which is radical 2. And the cotangent of 45 degrees is 1 over 1 again, which is just 1. So that was the 45, 45, 90. And then the other one was going to be the 30, 60, 90, because what they do is they start you out with an equilateral triangle, right? Each with length 2. So if they do that, and then you draw this altitude in here, you now create 2 right triangles, and it cuts this length in half. So each of those was going to be 1. And then what ended up happening is when you use Pythagorean theorem here, you solve, you end up getting that this is the square root of 3. So what ends up happening there is this ends up being your 60-degree angle here. And then this here ends up being your 30-degree angle, because that altitude there, right, that line coming down the middle, that cuts that angle in half. So instead of being 60, now it's 2 30s. And it does the same thing to this length, right? That whole thing was 2, so it cuts that in half, so each of those lengths is 1. So now that we have our picture, right, and all the angles are labeled, you can find all of the trig ratios of 30 degrees and 60 degrees. And you only have to look at one of those two triangles, either the left-hand one or the right-hand one, because they're identical. They're congruent triangles. So you can just label all the trig ratios. And there's all our trig ratios of 30 degrees and 60 degrees. Now, one thing that's actually important to note is that the sine of 60 degrees and the cosine of, the sine of 30 degrees and the cosine of 60 degrees are the same, just as the cosine of 30 and the sine of 60 degrees were the same. Because what ends up happening there is the adjacent and the opposite switch, right? So if you're dealing with 30 degrees, the adjacent is square root of 3. But then if you're dealing with 60 degrees, the opposite is the square root of 3. So they just switch places, the adjacent and the opposite, when you're going from 30 degrees to 60 degrees. So that's why you have that relationship between the cosine of 30 and the sine of 60, and the sine of 30 and the cosine of 60. And then the same thing with the tangent of 30 and the cotangent of 60, right? The tangent of 30 is 1 over the square root of 3, just like the cotangent of 60 is 1 over the square root of 3, because the adjacent and the opposite switch places. So you have that relationship between those angles because they add up to 90 degrees. So the last thing in this section is going to be the idea of using the trig ratios to solve application problems. So in this case, they give you the diagram of a building, I guess that's supposed to be, right? A wire from the top of a building is anchored 40.5 meters from the base of the building, creating an angle of 60 degrees with the ground. So what is the length of the wire? So this one we could use our calculator for, but actually since this is a special triangle, you could do this even without the calculator using your special 30, 60, 90 triangle. So we'll look at this both ways actually. So we'll first look at it just like we're using the calculator. So we know that this angle down here is 60 degrees. This side adjacent is 40.5 meters, and we're trying to find the length of the wire. That's interesting. I thought they were going to ask you for the height of the building. They're asking us for the length of the wire, which is this. That's the unknown. So in this case, you have the angle 60, you have the side that's adjacent, and you have the hypotenuse. So when you're dealing with adjacent and hypotenuse is going to be the cosine. So you're going to use the cosine of 60 degrees, and that's going to be the adjacent, which is 40.5, over the hypotenuse, which is c. And just as we did before, you're going to cross multiply, so you're going to have c times the cosine of 60 degrees is 40.5, and then you're going to divide both sides by the cosine of 60. So you end up with c equals, or c is approximately equal to 40.5 divided by the cosine of 60, and 40.5 divided by the cosine of 60 is 81, exactly 81 meters. And this should make sense now if we think of this as a 30, 60, 90 right triangle. Because remember, when we drew our 30, 60, 90 right triangle, well, here, I'm just going to use this as a diagram. The side that was opposite the 30, we called 1, right? So we can call this 1x equals 40.5 meters. The side that was opposite the 60 was the square root of 3. So we can call that the square root of 3 times x. And then c we had called 2, which is the hypotenuse, right? The side opposite the right angle, the hypotenuse, we had called that 2. So now we'll call it 2x. But we already know that 1x equals 40.5. So if we know that 1x equals 40.5, well, 1x is the same as x. So x equals 40.5. So if we want to find out what the hypotenuse is, it's just 2 times x, which is 2 times 40.5, and that's going to be 81. So we could have done that just with the special triangle. But you can always use the calculator also, because realistically, I mean, application problems you generally want to do the way you do it in real life, and the way you do it in real life would be on the calculator, right? You probably wouldn't use the special triangle relationship.